Okay, this video is over chapter 3 of your textbook, which is entitled Host Side Artifacts. So back in chapter 1, we talked about what artifacts were, but just to refresh your memory, an artifact is anything of interest related to whatever we are investigating. Now, related to this chapter, host side artifacts, these are artifacts that reside on the host computer that we are looking at. And examples of these would be things like the registry keys for the machine. There may be file system artifacts. There may be malicious files we encountered. There may be legitimate files or executables that have been renamed. We might look in temporary files in case something is stored there. A lot of times attackers try to hide files by setting a hidden attribute. So we might want to look for those. And we might want to look for files that have unusual file extensions. Some more examples. We have processes that are running on the computer. We might want to capture all those processes that are running and some attributes of those processes. A lot of these processes are going to be scheduled as services running on the computer, so we would want to record that information. Those services might be scheduled tasks. We might also want to look at log files. Some OSs with proper configuration can actually record the commands that the users have issued. If our system does that, we might want a command line history. We might want to look at browser activity and user activity on the machine. We might want to do a memory dump, which is making a copy of the contents of memory or a portion of memory on the machine. And there may be host-related network artifacts, that is, artifacts that involve communication to and from the host we are investigating. So diving a little deeper into services, a service is a program that runs in the background, and its purpose is to provide some type of functionality to the users or other programs on the system. Now, how those are implemented, in Unix, they're called daemons, spelled D-A-E-M-O-N-S, not D-E-M-O-N-S. And I've asked my students before when I've taught in class what they think that is. And they say, oh, the first common answer is that's the British spelling of demon. Well, that's not correct. So they'll make some guesses, and I don't think I've ever had anybody guess it. So then I tell them that demon, spelled D-A-E, is more helpful spirit or ghost as opposed to something evil or bad. And then my standard Unix joke is some people claim that Unix have both, demons spelled with an E and demons spelled with an A-E. But daemon is a background process that is running on a Unix or Linux machine. Windows, we can have applications that run in the background. If you're using Windows, you can use the services snap-in, services.msc, to view the services that are running. So here's an example of a screen grab of a portion of the Windows Server applet running. On Unix, the closest equivalent that we have is system control list units -- type equals service. If I issue that command on a Unix machine, this is the output I get. So a lot of the same information. So whenever possible in this class, I will try to always tell you how you do it on Windows and how you do it on Unix. And, if we're concentrating on something that's primarily Windows related or that was created in the Windows world, I will try to list the Unix equivalent, and vice versa. If you're on Mac OS uses a system called Launch Control. And if we issue the Launch Control -list to list the services running on this Mac machine, you will see that this looks very similar to what we saw in the Windows world, as far as information provided to us about some of the services running on the machine. Now, where do these services start from, or how are they started? And we'll start with Linux first. There are different directories that contain files, often shell scripts, that start up services. Lib systemd system, etc systemd system, etc init.d, etc rc3.d is an older directory. Basically, the RC3 is its run control if the operating system is running at level 3, which means it's allowing users and user processes and logins. For Windows, we kind of have the same thing. They can start from the System32 directory. They can be started from program files. They can be started from program files x86. And then you can specify other locations in the services applet as to where these services are starting from. On Mac OS, I told you that they use something called LaunchD. So LaunchD will look in System Library Launch Daemons, Library Launch Daemons, System Library Launch Agents, Library Launch Agents. In the user's home directory, library_launch agents. I'm going to kind of sidebar here for a second. When we're investigating things, we need to know a lot about the file systems and how they are laid out. I plan to do a supplemental lecture on that. We also will learn things about what's relative and absolute path names and different things. So if you haven't used Unix before, this path might look a little strange to you. It has the tilde, the little squiggly line, and what that refers to in a Unix environment, and Mac OS is Unix underneath. So that tilde means, in my case, my home directory in a subdirectory called library and a subdirectory called launch agents. So tilde is an easy way to say my home directory. In reality, it's /users/Wayne is what would get substituted there, because that is the location of my home directory on my Mac where I was gathering this information. Now, another thing we might need is, I mentioned network-related artifacts related to the host. And the first thing is connections to and from the machine. So the first thing I want to do is review a couple of concepts. These were born out of the Unix world a long time ago in the 70s and 80s. But I want to review what a port is. And a port is an abstract thing, and therefore sometimes it's a little difficult to explain what it is. But the easiest definition is it's an endpoint for communications. So if you connect to a web server wanting to retrieve a web page, you would connect, to example, to port 80, which is the HTTP port. And on your local machine, there will be a port on that end. And if you're connecting to a port on a remote machine, you get on the local machine what's referred to as a dynamic port. And it will be a random large, when I say large, 5 or 6 digits number that will be used to keep track of that conversation you're having with the web server somewhere out on the internet. So need to know what a port is. The other thing I'll mention it's not relevant now, but maybe in the future. This is also referred to as a socket, and we have something called a socket pair, which will be the pair of ports that define where a conversation is happening. So, for example, it would be your IP colon the dynamic port on your machine, and on the other side would be the IP of the remote machine, and whatever port, in this example, port 80, would be the socket pair. So it tells who's communicating to what down to the port level. The other thing that you often need to know in networking classes and or cybersecurity classes is what's known by a well-known port. So there's a couple of facts about well-known ports. They are ports that are below 1024, and often you have to have administrator rights on the machine to be able to open up a port listening on a port below 1024. Some of the well-known ports are for HTTP, there's port 80. Port 443 is the Secure Web Protocol, HTTPS. Port 25 is for email, SMTP, Simple Mail Transfer Protocol is what that stands for. Port 22 is Secure Shell. That is a secure way to interactively log into machines or to run commands like scopy, SFTP, etc. over. We have FTP, File Transfer Protocol. It actually uses two different ports, port 20 and 21. And then we'll be talking a lot about DNS in this class. And DNS happens on port 53. So these are some of the ports that you need to commit to memory if you don't already know those. If you've had 160 or 161 or internet protocols, which is 150, you might know these, but if you don't know them, you kind of need to start getting used to at least these more common protocols. And over time, I may add a port here and there that you need to be familiar with. TCP connection states. This is a lot of detailed information. Normally in my networking classes that I teach, I would not go over this just because we know they happen. We might talk a little bit about handshakes and that type of stuff, but a lot of times you can hack a system or do a denial of service attack on a system by messing around with these connection states and either not going through the process correctly or opening up connections incorrectly. So I want to run through these real quick just so that you are familiar with them. If a connection is closed, that means the communications has stopped. Earlier I mentioned something called listening. Listening is when an application has bound to one of these ports and is sitting there waiting or listening for a connection. So web server software listens on port 80 and or port 443 for some client, some browser, some person out there to connect to it. And when they do connect to that port, it establishes a connection and then talks the HTTP protocol to request and send back a web page. There's send-sent. So this is what the client typically sends before a synchronized message. There's a receive that tells when a send has been requested. I mentioned a handshake. If the three-way handshake to establish a TCP connection has completed, then that connection state would be listed as established. Fin wait means I have requested a finish, which means I want to terminate the connection, and I'm waiting for an ACK from the remote machine to say, okay, I understand that, and I'm okay with that basically. Close wait, I've received a fin and I've acknowledged it, and I'm waiting for the other side to actually finish or close that connection. Closing, I'm in the process of tearing down the connection. So one side has probably completed tearing down the connection, and we're waiting for this machine to tear down the connection. Time to wait. Some things in networking, especially when we don't know when we'll get a response, have timers. So a time wait means I have sent a fin and I've acknowledged it, and I'm going to wait to receive my acknowledgement back. And if that timer expires, I'm going to assume something is wrong. Now, there are tools for examining the connection states on host machines. Born out of the Unix world, but available on Unix and Windows these days, is NetStat, which gives you a network status which can display or include network connections. There's a couple of common options. -A means show all sockets regardless of whether they're listening or non-listening sockets. -N means don't give me things like google.com, actually give me the IP name. Also, for ports, it will have things like HTTP by default, but if you use the -N option, instead of putting HTTP there, it would actually put 80. So you can either get the name, more verbose output, or you can actually just get IP numbers and port numbers, whichever you want. A lot of times, or sometimes anyway, we'll need to look at routing tables. NetStat with the -R will give you the routing table for the local machine. A lot of times when you have a machine that you think is hacked or misbehaving, NetStat will often be one of the first commands you issue to see if you have any, quote, strange connections to your machine from, other countries, for example, when there only should be connections from your country or your state. Are there unusual ports? Are there non-well-known ports that have connections on them? You'll need to determine, is that because you're running a piece of software that listens on that non-standard port, or has somebody installed, for example, a botnet that is watching on that port? On a Unix machine, this is what you'll see. I think this is from my Mac, but it tells me, the local address, which is my machine, dot, and in all cases, except the last two, those are dynamic ports that are connected to foreign addresses. Name or IP address if name's not available, dot, and most of those are doing HTTPS, but there is a couple of IMAP connections, which is an email protocol. So all that looked normal, but just to tell you why you might discover things is I did this on my laptop to grab a slide to put in this presentation. And I saw those last two connections, 59101, and they're actually listening. And I was like, okay, that's really strange. So I did some investigation, and the software that I use to create my presentations in this class is a piece of software that was developed for Steve Jobs originally, for him to do presentations at Apple's Worldwide Developer Conference and or Macworld, that was named Keynote. So Keynote is the presentation software I am using, and it actually listens on port 59101. So I was like, okay, fine, so it's a legitimate piece of software, but why is it listening for anything? And I had to look it up, and it's for allowing remote presentation control and or device-to-device communications. So, sometimes you might see something strange and think you have a problem, but after a little investigation, you'll figure out that it was fine, that you weren't hacked or something, that it's just a piece of software that I had running at the time that was listening on ports in this case. On a Windows machine, same command, similar output. So you can do netstat pretty much on any operating system you might be on. So those last few slides were on the -A option. Now, if I look at the -S option, the S means statistics. And when I ran this on my local machine, I got 126 lines of output. I tried to grab some interesting complete sections here. So at the top, I have information on IP packets. Since my machine has been up, it's received almost 500 million packets, 500 million IP packets. And then it tells how many were TCP IP related, tells me if there were any bad packets or drop packets, that type of thing. So netstat-s, depending on what you're looking for, might be interested. If you think that somebody has installed, peer-to-peer network or software sharing, file sharing software, you're going to see a lot more packets than you would on a machine that was not running that type of service. NBStat is something I included because it's talked about in your textbook. It is old. It was originally designed for NetBIOS, which is networking from, early Windows operating systems from the 90s and early 2000s. I tried to find a copy just so I could run it and show you what it did. And it's so old that I could not find anything. I could not find a copy of that software. I could not find a Unix equivalent. So the book talks about it. You might read that section. If there's any images there, you might study them, but not something that we will be using ongoing in the course. Next, we have ifconfig. This is an abbreviation for interface config. This was born in the Unix world, and it was a way to get information about your network connections. Some of the most common usage are ifconfig-a, which is show me interface information on all, that's what the A stands for, of my network ports or network connections. If you only care about one thing, for example, if I only cared about my wireless, I would use this form of the command and issue ifconfig space EN0, which is the default networking wireless connection or port on my laptop. Now, here is an example of ifconfig on a Unix machine. So you can see that it gives me my interface EN0, gives me some information. You can see where it says ether EA colon. That's my MAC address, my hardware address, my Ethernet address, my physical address. Those are all different names for MAC addresses. It tells me my IP version 6 configuration information, and then down towards the bottom where it says INET, that's my IV version 4 information. So my IP address is 192.168.0.132, and my net mask is 255.255.255.0. And my broadcast address is 192.168.0.255. So you should be familiar with IP address, subnet mask, network math to determine the network number, the broadcast. Also, we'll have some videos on how do you look at an IP address and figure out, is this a network address, a broadcast address, or a host address? But if you need information about the local machine related to networking, and it's a Unix machine. Ifconfig is the way to go. Now, we kind of have the same thing on Windows, but for whatever reason, they changed IF for interface to ipconfig. And, maybe that makes more sense because it's going to give you the IP configuration, but the behavior is the same. There's an option to show all my interfaces, which is /all. And if I do that on a Windows machine, you will see that it gave me some information. I didn't do IP, well, I guess I did do /all on that machine. Now, here's a continuation. It was too long to get on one slide. So here's the stuff we really care about. Notice they call the physical address is the name they use for MAC address. This machine is using DHCP. There's its IP version 4 address. There's its subnet mask. And we actually have information about when DHCP gave us a lease on that IP address and when that expires, and also the default gateway, our DHCP servers, our DNS servers, etc. So that gives you a lot of information about the IP configuration on a Windows machine, just like ifconfig did on a Unix machine. Next, the book talks about something called sysinternals, and this is a set or a suite of Windows software that exposes internals of the Windows operating system. And we can download that from this URL. I will probably have you do that at some point once we get to the point where I can provide a Windows virtual machine for each student via AWS Academy, which will have an assignment coming up to complete the registration process and start setting up VMs that we will be using for this machine. Once you download this to a Windows machine, if there's any Unix people out there, you may find this humorous. If you're not a Windows or Linux person, you may not understand why this is humorous. But to extract this, the command you use is tar-xf. The reason that's funny is the tar command is a Unix command that you use for extracting archives that are in the tar format. So instead of using unzip, which is the first thing I tried, it's actually tar-xf on modern Windows machines. I plan to make a separate lecture. There are probably 20 plus different subcommands under sysinternals, and I plan to make a lecture that exposes you to some of those, at least the more common ones, and at the same time will give you the equivalent way to accomplish the same thing on a Unix machine. A couple of examples, a couple other pieces of software are ntop. Unix had a top command which shows you the top processes, that is the processes consuming the most CPU or most memory, etc. Somebody created something called ntop, which stands for network top, and this is a tool for seeing which processes are using the most resources. So ntop for Windows, you have to have WinPCAP installed. By the time you're seeing this, presumably you have done, I believe, Homework 6 or Homework 7, whichever was installed WinDump. So you should already have WinPCAP on your system if you got WinDump to work correctly. And then you need to install the ntop ng, which probably stands for new generation or next generation application. It's an updated version of the original ntop. You will need to start a service that processes the information and provides a web server running on port 3000. So you would need to connect to port 3000 and you will get output that looks like this. So it'll tell you the name of the machine, its IP address, how many flows, which at this point you can think of that as conversations has it had, and how long has it been running or consuming network resources. So that's NTOP. Task Manager for Windows machines allows you to look at a lot of different resources that are being used on the system. Here we are looking at CPU and memory usage of the processes. That is something that might be handy to know if we're investigating a potential breach. Here we can look at the Ethernet and see how many packets are being sent and received and how much network bandwidth is being consumed. We can also look and see what processes are sending and receiving packets and how many they have sent or received. And then over on the right, we have a network graph of network utilization for different types, including, you'll see Ethernet 0, which is one of the interfaces on the machine. Another thing that we will be talking about in this class is the ARP command. You should be familiar with this already, but ARP is Address Resolution Protocol, and the purpose is to map IP addresses to MAC addresses on the local network. So one thing that I harp on, and I think I've already mentioned that when I say I harp on this, that means it's going to be a question that will probably appear on homeworks, quizzes, and or exams. But I will ask you what type of addresses are used to communicate on layer 2 of the OSI model, and the correct answer is simply MAC or MAC address. You know, no elaboration. A lot of times students say IP addresses and MAC addresses, and it's like, no, it's just a MAC address. So ARP allows you to be given an IP address and then get a MAC address on the local network so that you can communicate with that machine. Now, if I ask you what addresses are used to communicate with machines on remote networks, then your answer is simply IP or IP addresses. So you will see that multiple times. I can pretty much guarantee that. The other question you will see is what 3 pieces of information need to be correctly configured on a device for it to communicate with machines over the internet. The correct answer is it needs an IP address, it needs a subnet mask, and it needs a default gateway. You will see that question many times. To display the ARP tables, you use ARP-A, and when you do that, you will get all the ARP entries that are currently cached on your machine. Now what happens is we do an ARP request, which is basically the machine going, hey, who on the network has this IP address? And somebody will respond back and says, I have that address, or I know how to talk to that device. So here's my MAC address. And it will record it in the ARP cache so that the likelihood that you communicate with that machine again and again and again, at least for a little while, is high, so that you don't have to go through the ARP process over and over again. So it will first look in the ARP table to see if it can get an answer, and then if it can't, it will broadcast an ARP request out over the local network. The next thing your book talks about is the /proc file system. /proc exists on some, but not all, Unix and Linux systems. For example, Mac OS is Unix, but it does not use the proc file system. What this is a pseudo file system, which means it's not a real file system, but it looks like one, that exposes kernel and process information. Here's an example of me on I can't remember what version, it's probably SUSE Linux, cd to /proc and did an ls. Those things with numbers correspond to processes that are in use on the current machine, and then some other common things related to paging, the load average, kernel memory, and that type of thing. And if you CD down into one of those directories, you will get information about the memory being consumed, files that are open, and all kinds of information about the process that has the number that matches with the name of the subdirectory n/proc. So that finishes up chapter 3 of your textbook.